jumping on to number 9. Number 9 is using components with known vulnerabilities. So to give you an overview, known vulnerabilities are documented in public databases. You may not already know this, but there's a couple in particular that are referenced by cybersecurity professionals as well as hackers that are looking to do something bad with your web app. Number 1 is the NIST National Vulnerability Database, or NVD. Another database is MITRE. They're Common Vulnerabilities and Exposures database, but they refer to it more as a dictionary. So it's sort of like a dictionary to look up different vulnerabilities. They just try to document every possible one, and they're government supported and funded as well, like NIST. So our taxpayer dollars help them. Modern apps mostly use third-party code. So using components with known vulnerabilities is pretty much always going to be something to worry about unless you write your web app or your whole website completely from scratch, which would be extremely difficult and time-consuming to do depending on what you're doing. If you're taking a lot of user data and stuff, then yeah, it's gonna take a long time to get that really secure. But if you just use something like a platform or framework to build your app on top of, you're using mostly third-party code. So like if you're building a website on WordPress or Drupal, you wanna check those, check the websites for those different CMS softwares, and you wanna make sure that any vulnerabilities that they have listed as known vulnerabilities, that you're aware of those and make sure that those can't be used for bad in your application. It might just depend on the vulnerability and how it's exploited and the risk. So attackers have many methods to scan web and mobile apps for third-party code. They use the same tools that legitimate cybersecurity professionals use. They use vulnerability scanners and fuzzers to just script and automate these kinds of discovery scripts where they find these vulnerable servers or apps on the internet, and then they might have the script automatically try some exploits against it too to see if it's worthy enough to, warrant manual time and effort on their part. So it can make their job a lot easier using vulnerability scanners. If a third-party library you're using is vulnerable, then your app likely is as well. As I said before, if WordPress has a vulnerability that's known and your app is built on WordPress, it's likely vulnerable as well. And you need to make sure that you install the security patch for that vulnerability as soon as possible, as soon as it's available. If any part of your full stack for your application is vulnerable, your app is as well. So on the left, I depict the stack in a little diagram showing your app, your platform, your database, your operating system, the network. Usually, if you're just a web developer, you might only be front end, so you might only have to worry about the app portion of that, the very, very top. While everybody else for your service provider worries about the platform, database, operating system, and network portions of it. Makes the web developer's job a lot easier. As I mentioned, the OS and network, usually the responsibility of your hosting service provider. Full stack web developers, however, will need to be aware of not only the app layer, but the platform and the database layer, and maybe the operating system layer. But usually it only goes there. It doesn't go beyond that to the network layer. That's usually mostly automated. You're usually not granted access to that kind of stuff when you're using a service provider to host your website. So the impact that this can have is just about anything. Depends on what your app is used for, what kind of data your app is storing and using, as I've said. For an example from the real world, everybody has heard of the Equifax breach from 2017, I'm pretty sure. Everybody should have, because everybody is impacted. Just about every American in this country had their personal information stolen in that attack. So names, addresses, dates of birth, social security numbers, and driver's license numbers of nearly 150 Americans were stolen, plus around 200,000 credit card numbers in this breach. It was caused by a widely known and documented vulnerability, which is the most amazing part. The vulnerability was out there for months before it had even started being exploited by an attacker. And then after that, it took them months to be able to even see that this was going on. And then they decided not to tell anybody about it. They decided to kind of keep it quiet for a while. They neglected to patch for several months, as I said, and that left them open to attack, and attackers got in. They then later on pinned it on one IT guy and fired him. That's not an actual picture of the guy. That's from a movie called Office Space, and it's from 1999. If you haven't watched it, you should. It's pretty funny, and you'll see this character. His name is Milton. He got fired in the movie and then burned down the building. So the different vulnerability databases we're going to talk about real quick that I just want to show you so you have some familiarity with these is the NIST NVD, which is the National Institute of Standards and Technology National Vulnerability Database. It's owned by the US government, and they research new vulnerabilities and assign a score and assign, they put out remediation information for them. It's a huge database, and it's been around since the 90s, I think, to try to have a central information repository for vulnerabilities. There's also something from an organization called MITRE. They have the CVE database. It's basically the same thing, except it's more of just a dictionary for all the publicly disclosed vulnerabilities. And that's what it looks like when you're looking at a vulnerability. Specifically, that is CVE-2020-1350. And that's a fairly recent one. That was a really bad vulnerability with Microsoft DNS servers. So to prevent this vulnerability of using components with known vulnerabilities, you want to start with the software. Remove any unnecessary dependencies, features, components, and files. Think back to the XXE and external entities vulnerability I mentioned. The unnecessary features might be your external entities being enabled or DTD being enabled in your XML parser, so you need to disable that. Take inventory of your dependencies and third-party software used. Remember that the full stack has an impact on this, so you want to take inventory of any software and versions of that software you're using at every layer in the stack if you're managing all those layers. You want to update your software, but read any release notes and information surrounding the patch or the security update for any surprises first. Sometimes there might be something where configuration is needed before or after the patch is installed. You don't know until you read those notes. Virtual patching is something I'm not going to dive into, but it's basically using an IPS or an intrusion prevention system to prevent exploits in your applications. It's really, really complex, but it's really worth looking into if you want to get a lot deeper understanding and knowledge of vulnerabilities. There's a whole virtual patching best practices cheat sheet kind of thing on OWASP site that I have linked here if you want more information on that. Some proactive steps you can take to avoid this is number one, scan your app, site, servers, or network for vulnerabilities. Every part of the stack you have control over, that you have access to, you want to be scanning that for vulnerabilities using a vulnerability scanner. And there's a lot of scanners out there. There's a lot of open source free ones that hackers use as well. You can use those for legitimate purposes to find any open vulnerabilities on your website, or pay a cybersecurity professional to do that for you and give you a report or advice on fixing those. You want to budget for future maintenance. This means time, money, and effort. You don't want to assume that your app that you just built today and is secure today will be secure tomorrow. That can always change with a little bit of time. For further reading, let's see the OWASP dependency checker. It's actually an app developed by OWASP to list out all the different dependencies for your application. And it's available in a lot of different languages. So it's really, really useful for number 9 specifically.